Hi, welcome to another EC&M Tech Talk. Today, limited energy and communication wiring. You know, low voltage wiring like this. Everything from twisted pair to optical fiber cable like this or whatever. That's what we're going to be talking about today. And the reason is because there's been some big changes in that for the 2026 NEC. Not a whole lot really in the technical content, but if you do any of this low voltage wiring, you're going to need to know where to go find this information in the 2026 NEC, right? So that's what we're talking about, where all this information is. In fact, we now have a definition for limited energy systems. I mentioned low voltage wiring because that's the way we talk out in the field, isn't it? But there's no definition in the code book. It doesn't differentiate between low voltage and whatever normal voltage 480 is, or 208 or 120, or a medium voltage and 4160 or high voltage or anything like that. Okay, what the code talks about is limited energy systems. So that's where we're headed today. Now, we're going to first look at this definition, and then we're going to move into Article 720. Article 720 is a new article, but it covers the general requirements for limited energy systems. So we'll go somewhat in depth into that. Then the next thing we're going to do is we're going to take a look at several new articles for limited energy systems. Alrighty, and see what kind of information is in those articles, where we would go to find that information and even to find the article itself. Alrighty, then we'll take a quick look at Chapter 8, which is communication systems. However, even the title for Chapter 8 in the 2026 NEC changed. It's no longer just communication systems. It's now communication systems for, outside and entering the building. So that's a little bit different. And so we'll talk about that as we wrap up the day. 100, Article 100, we have the definition for limited energy systems. And here's what it revolves around. It talks about these limited energy systems are somehow power restricted, or they somehow limit or shut down the power to mitigate the hazards of shock and fire. So it kind of makes a sense. If I install a system and under normal conditions, I wouldn't expect to get a shock from it, even if I touched an energized conductor, and there's really not enough energy there in order to cause a fire, maybe I don't need to follow all of those same installation requirements that I might have to on a 240 or a 480 system, something like that, certainly. There's a good informational note at the bottom of that definition that's going to tell you what some typical limited energy systems are. Class 2 and Class 3 systems. Class 4, which first appeared in the last edition of the code, and power limited fire alarm systems. Those are certainly power restricted, and our communication systems as well. How do they do all this? We'll talk more about it as we get into it, but through inherent design within the equipment. So, a lot of the information now has been rearranged in the code book. Chapter 7 now contains several articles just on limited energy systems. So we want to discuss those, or that's what we will be discussing, is what's in those different articles. Chapter 7 has now been retitled as well. It's titled Specific Conditions and Systems. And then Chapter 8, as I mentioned, we took a lot of information out of Chapter 8. It's no longer a standalone chapter, and it's now in Chapter 7. So communication systems outside and entering buildings, we said, is our new title for that article. So let's begin with Article 720. Article 720 is titled The General Requirements for Limited Energy System Wiring Methods and Materials. 720.1 is the scope, as it is throughout all articles in the code. And it tells us that what's it talking about in Article 720? Well, things like signaling, fire alarm systems, broadband, so forth. In fact, there's a table 720.4a, which gives you a list of, a dozen or so different applications. So that's a good table 720.4a, to take a look at to see where do these limited energy systems apply. There is an informational note that says, hey, if you're talking about communication systems outside of a building, go take a look at Article 800. Now, listing requirements, global change throughout the NEC. .2 is now listing requirements. 720.2 says that communications equipment must be listed. Probably no surprise there. There is an exception, however, beware, an exception for temporary test equipment used by qualified persons. Doesn't have to be listed. 720.5 gets to be pretty important. It talks about underground installations. The first subsection it talks about is wet locations. And it says that, and really, by the way, as we go through Article 720, you might be saying, that sounds a lot like Article 300 back in Chapter 3. And yeah, our general wiring methods in Chapter 3 and Article 720 are in Article 300 and Article 720 closely parallel each other. But anyway, back to 720. 720.5 says that in our underground installations, even if I put these conductors inside of a raceway, like a conduit, if that conduit's in a wet location, then those conductors are in a wet location. Now, there are some requirements for marking requirements on those conductors. However, we're also going to find out there's some exceptions to the marking requirements. And as you might guess, I'm talking about things like it's identified for a wet location or something like that. Alrighty, but we'll see. Subsection B is on swimming pools. If you get involved in any communication, limited energy wiring around swimming pools, it references you to Article 680, which is swimming pools. No surprises there. Subsection C of 720.5 talks about when I go underneath a building with my limited energy run. The general rule is underground limited energy cables installed under a building have to be in a raceway. Okay, that makes sense, and we normally do that. But there's some exceptions. It says if I run any one of 3 types of cables, I don't have to put them in a raceway. Optical fiber, communication cables, and coaxial type CATV cable. Coax, right? Okay. There's a similar requirement now in 720.11 for cables above ground. There's an exception for these cables do not have to be in a raceway above ground in a wet location. But it adds one more cable. It adds network-powered broadband cables as an exception as well above ground. Now, cables emerging from grade. We know the general rule is what? We're going to protect cables when they emerge from grade. Once again, no an exception for fiber, communication cables, and coax. Also, 720.5 talks about, just like in 300, it talks about backfill. I've got to have clean backfill, no concrete, things like that in my backfill. I have to have a bushing, right, where I emerge from grade on that conduit, except for limited energy systems, a seal is permitted to be used in lieu of a bushing if it also provides that same amount of protection to prevent me from damaging that cable. Subsection G talks about earth movement. I lay my conductors in an S inside of that trench to allow for any earth movement. Directional boring, my cables or raceways, limited energy cables, raceways being used, must be approved for the purpose. Really same as in Article 300 then. 720.6 talks about protection against physical damage for my limited energy cables then. General rule, I got to give them protection, right? I can use any raceway that I use in Chapter 3, rigid, EMT, PVCs, whatever, okay? As far as my fill requirements in those raceways, same thing. Go to Chapter 9, Table 1 for my fill requirements. When I go through a wood framing member, the edge of that hole has to be 1¼ inch back from the edge of my framing member then. Or I have to put that steel plate over it. Bushings or grommets are used if I go through a hole when I'm pulling those limited energy cables through metal framing members. Once again, to give them physical protection, right? 720.7 says I have to protect my limited energy cables from protection against corrosion, deterioration, If exposed to sunlight, they've got to be marked sunlight resistance. Raceways exposed to different temperatures comes a condensation issue, so I have to use sealants or other approved means to make sure that I don't get any condensation on either side of that raceway then. Dwelling unit communication outlets is 720.9, and it says it applies to new construction, and it says I have to have at least one communication outlet in that dwelling unit. It has to be in an accessible area within the dwelling unit, and it's got to be cabled to the service provider's demarcation point. So when that service provider comes in with the internet, whatever, and hooks up to that demarcation point, bingo, now I have that service all the way out to that communications outlet. 720.10 talks about installation of limited energy cables and conductors with non-electrical systems. Doesn't sound like a good idea, huh? It says don't intermix them is what it's telling us. Don't intermix your limited energy systems with mechanical type systems, piping, plumbing, and so on and so forth. Limited energy systems in wet locations above grade, mentioned 720.11 before, but nonetheless, it talks about it's above grade, considered in a wet location. Then I would have to use conductors that are marked for a wet location, listed for a wet location. However, exceptions again, as I mentioned, for fiber, communications cable, coax, and network-powered broadband low-power cable. 720.19 talks about supporting my cables and conductors in vertical raceways. Probably the big number we run into here is 100 feet. So if I've got a vertical run of 100 feet, up as near as I can to the top of that run, I want to go ahead and support those limited energy cables. Different ways I can do that: clamps, wedges, properly supported boxes, I could use that. And then basically what it says, every 100 feet afterwards in that vertical run, it'd be a pretty long vertical run, but I would have to go ahead and support those cables again. Now, 720.21, always a big issue, fire stop, okay? Spread of fire of products of combustion. We want to minimize that. So we have to use fire stopping or other approved methods in order to prevent those transfer of not only fire and flames, but products of combustion from one area into another. 720.22. It's a mouthful just to say the title. Then we'll break it down and talk about it. But 720.22 says wiring in ducts not used for air handling, fabricated ducts for environmental air, and other spaces for environmental air, plenums. What we're really talking about here, very similar to what's in Article 300, we have three spaces that we're talking about. We have wiring ducts that are not used for air. That's number one, not used for air handling. So what would that be? A duct that maybe transports dust. And if you think about it, probably the big issue with dust, I don't want fire and explosion caused by some electrical fault inside of that duct. So we're not allowed to use even limited energy cables inside of those ducts that are not used for air handling, used for something else. Now, the second item it talks about is ducts, fabricated ducts for environmental air. So now back at the shop, they've taken some sheet metal and they made up some ductwork, and they're going to run that from the rooftop unit down into my building, and they're going to have some sensors in there and some dampers and things like that, and we've got to be able to control all of that and get feedback from the sensors, whatever it is we need. And so we can run limited energy systems within those fabricated ducts for environmental air. However, they say, well, only if it's really necessary. And then it gives provisions for uses of things like MC cable, MI mineral insulated cable, and so forth. And then finally, the third area that they're talking about, this other spaces for environmental air. And the code even mentions this in the informational notes, not only within this article, but elsewhere. And it talks about that these spaces are typically what? Above a suspended ceiling. So what do I have? I've got my rooftop unit up here, and I've got my fabricated ductwork that brings my ventilation air in and distributes it throughout the building. And then within that suspended ceiling, I have certain tiles that have a vent work in them so that that air can return back up through the vent work and be pulled across the top of the ceiling tile and then back into that rooftop unit up top and, get heated or cooled, whatever, mixed with some outside air. And then that whole distribution system just continues. So those areas above that suspended ceiling where I have that return air, we call those plenums. Now, I can put, there's like listed cable where it says it's plenum rated. I can put those within that other space within that plenum. I can use maybe some listed prefabricated assemblies, or I can run it in some conduits. And it even lists things like EMT and rigid and intermediate metal conduit, flexible metal conduit. And I can even use surface mounted raceways, or I can install a metal raceway if there's no access available for people, right? So if there's no access to the surface mounted raceway, I can go ahead and install that. But generally, what are we going to do? We're probably going to use some listed cable up there above that suspended ceiling, maybe run it in some EMT, whatever it is we're doing, okay? 720.23 ties right into what we just talked about. It talks about panels designed to allow access. If the panel is designed to allow access, and once again, as the code brings out, think about a suspended ceiling. If it's designed to allow access, it must allow access. Okay, well, hey, have you ever pushed up on one of those ceiling tiles, maybe in a commercial building somewhere, and you get it up about 1 inch, and okay, you're hitting some duct work or something like that. Also, it tells us is I can't allow for any accumulation of cables on those panels on the top. And I know you've never seen that happen before, right? Okay. I remember, one time, I pushed up a cable and it was like, or a ceiling tile, and it was like an avalanche of all of these cables that came down, falling on top of me. So that's not allowed. 720.23 talks about that. So it's going to tell us elsewhere how we have to support these cables above that suspended ceiling. Abandoned cables, of course, this has been in the code for some time. Accessible portions of abandoned cables shall be removed or tagged for future use. Now, let's talk about that tagging for future use. Certainly legitimate to do that. It does not mean I take a piece of white electrical tape and write on there with a Sharpie, it says future use, something like that. It tells me in 720.25 that that tag must be able to withstand the environment. So I need the right tag on that cable. Here are my securing supporting requirements in .30, right? As we see elsewhere and throughout the code. Securing and supporting. The general rule is we've got to support our cables. Why? And why do we do that? To prevent damage is what we want to do. Subsection B talks about limited energy cables in above a suspended ceiling. It says I can't support those by the ceiling system. I can't use the grid wires that are holding the ceiling up to support my limited energy cables. I can use independent support wires as one way, but if I'm going to use those independent support wires, they have to be distinguished by colors or tags it talks about. So what do? I probably get all of those independent support wires together before I ever first climb the ladder. Maybe lay them out on a piece of cardboard and spray paint them some color or whatever, okay? And then I put those up in the ceiling. Cable ties, it says, if I use cable ties in these areas, I must have low smoke properties, or the cable tie must have low smoke properties. Well, guess what? In Article 100, we've got a new definition, actually two new definitions, one for cable ties and one for cable tie support devices. And if you go back and look at those definitions, they're pretty straightforward. And you go, yeah, that's what a cable tie is. I use it to bundle or support something or whatever. But it says it must have low smoke properties. Read the informational note for cable tie. Very important. it explains to you what that means. So for instance, if a cable tie package has, what is it, like 21S marked on it, it means that it's suitable for supporting cables. And you wouldn't know that just from reading the label. It might say, you know, or the on the box of, or the container of cable ties or whatever, it might say plenum rated, something like that on it. But if you look at the informational note, it'll give you the information that you need to determine whether or not your cable tie meets the code requirements. And that's in Article 100, new definitions once again, for cable tie and cable tie supporting device. 720.32 is on boxes, conduit bodies, or fittings where required. Because remember, if I'm limited energy, maybe I don't always need those boxes like I do on that 480 or 240. So it gives provisions then in .32 for when my cables can exit a conduit and a box and not exit a conduit and a box not be used in order to pull through or terminate those conductors, whatever. It does require that on the end of that conduit, in that case, if I don't go into a box, I would have some type of protective fitting there, or if not the protective fitting, a seal in order to prevent damage to those cables as they come through. Let's move now into Article 721, and we'll move through these other articles, see what types of information are in them, because all of this information used to be somewhere else, all right? So let's see what's in these articles now. 721 is on power sources. Very short article. Power sources for limited energy systems. It's, I don't know, probably well less than a page long. Class 2 and 3 power sources have to be listed, it tells us. Then it mentions Class 4 power sources. Class 4, up to 450 volts, peak AC or DC. 450 volts, and it's still considered limited energy. And it's for, and what we have with these Class 4 fault mitigated systems, we have a transmitter and receiver. So we're talking about the power source, the transmitter, and the cables, of course, that run in between. 450 volts AC or DC applied to those cables. And you say that's limited energy. Well, like I said, we're going to either, in the event of a fault, either limit that energy so quickly or shut the power supply off so quickly that it will be safe. So, Class 4 mitigated power supplies, different topic, fascinating science, but anyway, that's now certainly in Article 722, or 721 is where it's mentioned, and we'll see it elsewhere as well. Now, Article 722, let's talk about this. Limited energy cables for powered limited circuits, for fault-managed power circuits, for optical fiber circuits, and communication circuits. This is a big article. It took a lot of information from elsewhere and put it into this one article. But what's nice about the way that all of this is rearranged now, I only have to go to one place to look for information rather than going all over the code to try and find out what I need. So what does this article cover? Our limited energy cables for Class 2, Class 3, and Class 4 power sources. And it covers optical fiber cable, fiber. That used to be Article 770. We had an whole Article 770 devoted to optical fiber systems. That has been deleted now, and now that information is in Article 722. And then we have communication circuit cables are also covered in Article 722. So really, to understand Article 722 on cables for limited energy systems and communication, let's take a look at the parts for the Article 722. There's a good informational note, 722.1, that discusses all this. But anyway, if we look at the different parts, we can see where we would go to find the information that we would need. And we'll look at a little more in detail on these. But anyway, Part 1 is some general information. Part 2 is pretty detailed. It gives us marking requirements on our cables. Part 3 is for limited energy cables and wiring methods. So remember the wiring method. Am I going to use conduit? Do I need conduit? What types? So on and so forth. Part 4, communication cables and wiring methods. Part 5, Class 2 and Class 3 cables and wiring methods. Part 6 is Class 4, fault mitigated cables and wiring methods. Part 7 is for our optical fiber cables. Part 8 is for our power limited fire alarm cables. And Part 9 is for circuit integrity cables, fire resistive cables, and electrical circuit protective systems. That's a lot of stuff in this article. The good news is there are lots of tables that tell you how to apply your articles in. So, if we were to take a look, for example, at table 722.100A, if you take a look at that one, you'll see that the columns are, we have our cables, the application of our cables, and then we have the different types of cables, okay? And it makes sense. So if I have a Class 2 cable, it tells me that's a general purpose Class 2 cable, and it's marked CL2. CL2P on this table would tell me it's a Class 2 plenum rated cable. Oh, that could be important, huh? OF, anytime I see OF, I'm talking optical fiber. So OFN is an example. It would be, tells me in the table, that's optical fiber or non-conductive optical fiber general purpose cable, righty? Now, for each of the remaining parts then throughout the article, you're going to find specific installation requirements for the particular cables. So take a look at the table and see what type of conductors you're allowed to run, and then go to the particular section to find out any specific installations requirements you need. For instance, always important, uses permitted and not permitted. Where can I install that particular cable? Where can I put it? Cable type substitutions. So we're allowed to substitute certain types of cable, maybe CMP for something else and so forth. And then, of course, any specific support and wiring methods are found within the article as well. So that's a big article, 722. Lots to review there, but it's logically divided up now for us. Once again, rather than having to jump all over the code. Article 723, raceways, cable routing assemblies, and cable trays for limited energy systems. Once again, take a look at the tables. Tables for different applications and what type of raceway or cable routing assembly may be used. Article 724, Class 1 power limited circuits and Class 1 power limited remote control and signaling circuits. So we're talking about maybe some motor control circuits, something like that. They're not limited energy systems. Yeah, they are power limited, usually to 30 volts or less and 1,000 volt amps max, but they're not considered to really mitigate electric shock and fire, so they are not limited energy systems, Class 1 power systems. But nonetheless, there's now a new Article 724 that covers those Class 1 systems. Article 725, Class 2 and Class 3 power limited circuits. Very short. It's only 3 sections. It tells us that Class 2 provides ways to mitigate both shock and fire hazards. Class 3 is only good for fire hazards because you see a Class 3 circuit actually has higher voltage limitations than a Class 2. A Class 2 is limited to what, 30 volts? So under normal conditions, that's not an electric shock. Class 3, I can have higher limits, and so it's not good for shock protection. So anyway, a little bit difference between Class 2 and Class 3. Listing and marking requirements are required then, and it spells out those requirements in Article 725. Class 4, fault mitigated power systems are covered. Fault managed power systems are covered in the article as well. It's covered in the next article. It's very short article. It's once again shorter than a page. And once again, we have the transmitter and receiver. Power is limited between these two. Excellent informational note. So what I'd encourage you to do, take a look at the article on Class 4, fault mitigated power systems, and read that informational note under the scope 726.1, so it's Article 726. Look at 726.1, lengthy informational note, gives you lots of information to help you understand these systems, as pretty soon you might be involved in installing these. Article 742 then, overvoltage protection. Overvoltage protection of limited energy systems. Another very short article. 740.10 talks about primary protectors, .20 about secondary protectors. And then .30 talks about how to install these protectors. What's the protector and all of that information about? Well, take a look at the informational note. There are informational notes that explain primary and secondary protectors. Lightning strikes in commercial circuits, we want to use a primary protector for that. In communication circuits, So to protect against lightning strikes in communication circuits, we use primary protectors. For voltage surges and things like broadband systems, probably secondary protectors. Now, Article 750, we always thought Article 250 is grounding and bonding. No, they took all of this information for grounding and bonding of limited energy systems and communication systems, and they grouped it all together into Article 750. So once again, a new article, grounding and bonding of limited energy systems. Consolidates all of that information from chapters 7 and 8, then into Article 750. It also took the information on grounding and bonding that was in our fire alarm systems in Article 760. So it grabbed the grounding and bonding information out of Article 760 and moved it over to Article 750 for grounding and bonding of limited energy systems. No real technical content changes. It does refer 750.94, refers you back to Article 250, Section 94, 250.94, for that intersystem bonding termination. And we see where we bring the power into our facility, we have our grounding electrode conductor going into the earth, right? Going to our grounding electrode system. And it says that we have to take all of these limited energy and communication systems and make sure that we bond them back to that grounding electrode conductor. And the way that we do that, we use a device called an intersystem bonding termination. Now, let's wrap up then with Chapter 8. So what have we seen so far? Lots of new articles in Chapter 7, but now we should have a feel where to go to find that information that we need in Chapter 7. Chapter 8 is communication systems. They've retitled it, we said. Chapter 8 is now communication system outside and entering buildings. Article 800 has the general requirements for communication systems outside and entering buildings. Article 805, that was in previous editions, has been really blended into Article 800. Article 810 remains on antenna systems. Article 820 on community antenna television and radio distribution systems. And Article 830 on network-powered broadband and communication systems. Some technical changes within Chapter 8, but the big thing is, Chapter 8, it's been changed quite a bit. The article, by the way, on premises-powered broadband systems has been totally deleted from the code. Chapter 8 is no longer a standalone chapter. It's the big deal, okay? So now its rules, the rules of Chapter 8, can be modified or supplemented by any other chapter within the NEC. So lots of changes. If you work in low voltage, then you need to know where to go now to find your information, because it ain't where it used to be, all righty? So as you go out and work on these low voltage systems, I don't care if you're going up on a step ladder to work above a suspended ceiling, if you got to terminate some of that fiber optic cable, be careful you don't prick your finger with that glass, and so on and so forth. You're going to be tying in power supply systems to all of these limited energy systems. So the bottom line is, you do all of this work, make sure you work safely, and we'll see you at the next Tech Talk.